Hey Grade 5. As part of our ongoing geometry work, I thought it would be helpful for you guys to review different types of angles and how we measure them, as well as the different ways that lines interact with one another. We're actually going to start with the latter, because it's really useful for when we're talking about classifying angles to have a certain couple of line definitions in our head for reference. Now, a lot of what we do with angles centers around a certain kind of intersection. So let's talk about intersecting lines. When we're talking about a pair of lines, there are two specific ways that they can run that are particularly important. The first are lines that run next to each other but will never ever meet. Now, I hear that we've got our reporter in the field to look at these. Now, I've enlisted the help of a top line-ologist to bring us some documentary footage of these lines in nature, so we're going to take a quick look with him, okay?
Thank you, Mr. Worthington. Now, here in nature, we can see the loneliest of all lines. These are called parallel lines. They go in the same direction forever and will never ever meet one another. Now, another thing you might think of for a parallel line is an equal sign. The two lines of an equal sign will never ever touch. Here we see another pair. Now, again, these lines will never meet, no matter how far they're extended in either direction. This is especially important when we're looking at the real world in examples such as the train tracks I showed you earlier. If those lines were not parallel, if those rails did not run parallel to one another, the train's wheels would be pulled in towards one another and the train would crash.
Thank you for that report, line-ologist. Now, if our lines aren't parallel, then at some point they must cross one another. They must intersect. This means that if I extend them far enough, eventually, either on one end, if not the other, they will cross. You can remember this word by thinking about roads. We have to put stop signs or traffic signals at places called intersections, because these are the places where traffic going in one direction and traffic going in another direction cross. At points where traffic intersects, we need to be extra careful. Now, there's a special kind of intersection. And for that, I've again turned to the experts, so let's pass things back over to our line-ologist.
Thank you again, Mr. Worthington. Now, looking at these two lines, we can see that they cross in a very specific way. In fact, each side of this intersection is exactly equal to the other sides if I were to superimpose a circle over this intersection of lines, like so. Wonderful. We can see that this circle is perfectly divided into 4 equal parts. Perfect quarters. If I'm splitting a circle into perfect quarters, or could with a line, I call this type of intersection perpendicular. Now, as every angle is a measurement of intersecting lines, we give these angles different names based on their relationships to these lines. You've probably heard of a 360 before.
Why, yes I have. You see, I'm a gamer, and we use that measurement quite a bit in gaming.
Wonderful. You see, in video games, you use 360 to refer to a complete turn because the measurement of a circle is 360 degrees. Now, when we're measuring angles, a 360 gets us exactly back where we started. Follow the pointer. 360. Now, the lines that we have here divide 360 into 4 equal parts exactly, meaning that each part of this turn, each quarter turn, is 360 divided by 4, or 90 degrees. We call these lines perpendicular, and perpendicular lines always make what's called a right angle. Like so. In fact, it makes 4 of them. because these four added together would make a full circle.
Well, thank you very much, line-ologist. Now, in grade 5, we actually only really need to know the definitions of 3 types of angles, and our line-ologist just helped us by showing us the first one, a right angle. There's 2 others, though. And there are actually 3 that we're going to talk about today, because why not have a little bit of extra information? These are all described in terms of their relationship to those perpendicular lines, or right angles, that we were talking about earlier. Let's start with one called acute. Now, acute is a word that can mean sharp or severe. It's actually the same root word as accurate. Think of a sharpshooter. Now, in math, we use this word to describe any angle that's sharper than a right angle. It's less than a quarter of a circle. A right angle is 90 degrees, so an acute angle is anything from 1 to 89 degrees if we're only using whole numbers. That means that any of these angles is actually acute.
These angles, these ones right here. Look at all these cute little angles. All less than 90 degrees.
Now those are our acute angles, and in grade 5, there's actually only one other that we care about, but we're going to talk about 2 more today anyway. The next one we talk about is called obtuse. Now, obtuse comes from a Latin word that means blunt or dull, but it's also taken on a meaning in English as a way to describe someone who's just being weird for weird's sake. Someone off in their own direction. Whether you take it to mean blunt or off on your own, though, both of those things could help remind you that an obtuse angle is, well, not that sharp. It's any angle in between a quarter of a circle and a half of a circle. Measurement-wise, this means it's got to be more than 90 degrees, but less than a half turn 180. Here are a handful of obtuse, or blunt, off-on-their-own angles.
Every single one of these angles measures somewhere in between 90 degrees and 180 degrees. It's wider than a quarter turn, but still less than a half turn. They are all obtuse angles.
So those are the angles we need for grade 5. There's only one more, and it's outside of the grade 5 curriculum. Now, to help illustrate this, we're going to need to cut back to the example angles, and I've got a collection of them. Because think of it this way. When you have an angle, we're talking about it in terms of how much of a circle it makes up. If it makes up less than a quarter of a circle, it's acute. If it makes up more than a quarter, but less than a half, it's obtuse. But with both of those, there's a whole rest of the circle that we're ignoring. And that's the last type of angle. We're going to have to give that a name.
Now you might recognize these 6 angles as ones that we've already used as examples of acute or obtuse. But if you'll look at the circles that I've drawn around them this time, what I'm trying to point out through that is that we're measuring the outside, not the inside, of these lines, the larger chunk. Now, we call this half or more of a circle that's left on the other side of an acute or obtuse angle. It's reflex angle. Now, drawing these can be a little bit tricky because it might look like you're just drawing an acute or an obtuse angle, which is why you need that half circle, that little dial around the outside, to really illustrate that you want to measure the larger part here. It's what that little line is for. Every single angle you could ever measure, if it's acute, obtuse, right, or even, yes, a straight line that's 180 degrees, has a reflex, has the rest of that 360 degree turn. So, outside of the grade 5 curriculum, but still worth noting, we have this extra category of angle that we call reflex.
And that's it, guys. That is your refresher on parallel, intersecting, perpendicular, and all of the different types of angles that we use in grade 5, and one that we don't use in grade 5, but you'll need to know for the future. Hope that was helpful. Hope that was a great refresher for you. And that's it. Have a cute day. Peace.